we looked at some new rules. Again, these rules do have to be memorized. There are no formula sheets on the AP exam, but we talked about the product rule, what to do when you are multiplying, when you're taking the derivative of two things being multiplied that both have x in them. We looked at how that could be extended when you're multiplying more than one thing together. And then we talked about the quotient rule. I mentioned that when you can avoid the quotient rule, that's often a smart idea because the quotient rule can give you a very messy problem. And then we saw how the quotient rule could be used to derive these rules for tangent and cotangent. Now we could do the same thing. I'm not going to derive it for secant and cosecant, but I will say, like in general, like we know secant is 1 over cosine. And I know that cosecant is 1 over the sine of x. You could take the derivative of those using the quotient rule, but I'm more concerned of that. You can just like memorize them and then use them correctly. So I am just going to give you the rule, but again, you could come up with these using the quotient rule. The derivative of secant is kind of weird. It is the product of secant times tangent. So we're going to say that the derivative of secant is secant of x times tangent of x. And the derivative of cosecant is the negative product of cosecant of x times cotangent of x. And so for the only notes today, I do have just like a slide to review all of our trig rules, and I just have 3 problems I'm going to give you a chance to try on your own first, and then we'll kind of check them. But to summarize all the trig rules you have to have memorized for this unit. So we will eventually find the derivatives for like the inverse trig functions, but in this unit we only have to have these 6 memorized. On Friday we first learned the derivatives of sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine of x. Yesterday we learned the derivative of tangent and cotangent. The derivative of tangent was secant squared of x. The derivative of cotangent was negative cosecant squared of x. And then today I just kind of told you we didn't prove it, but the derivative of secant is the product of secant x times tangent of x. And the derivative of cosecant is negative cosecant of x times cotangent of x. I know at times you'll be working like on this at home, so like you can obviously look at those formulas now. I will say like long run, the sooner you can memorize those rules, the better you're going to be at kind of what we have to do. Because eventually we're going to move beyond just like, can you find the derivative, but can you actually apply the derivative in different areas? One thing, I've mentioned it kind of briefly before, but I remember when I first learned these rules back in AP Calculus, it helped me to kind of keep track of what was negative and what was positive. I just kind of memorized it at all of my cotrig functions. So like cosine, cosecant, cotangent, those all had a derivative that was negative. And then basically all of your non-co functions, those all had a derivative that was positive. So for like, I guess we'll call it like classwork, it's really just notes. I just wanted to look at these 3 problems. Once we do these 3 problems, I'll basically go over them, and then you'll have the rest of the period to start homework or do what you need to do. And I just want you to find the derivatives of those 3 examples. Number 1, I think, is pretty straightforward. Do make sure you read it correctly as you're trying it, and that is sine times cosine. So you would need to use a product rule for one of those terms. The hint I will give you for the second one as you're starting it, that square root of 5, I would think of it as the square root of 5 as a coefficient times the square root of 5. So that square root of 5 acts as a coefficient. And I typed in the hint for the third one. If I see cosecant squared, I would think of that as cosecant times cosecant, and then do a product rule. But I'm going to be quiet for just a second. Feel free to unmute your mic or ask questions. But go ahead and see if you can find those derivatives. Don't worry about simplifying your answer. So just leave them ugly looking. But see if you can find those derivatives using the rules that we've covered basically Friday, yesterday, and then today. And again, you do not need to simplify. In fact, most of these don't simplify that nicely. So there's the first one if you want to check your answer against mine for the first one. So in blue, that's where I took the derivative of 5 times secant. 5 is a constant multiple, so it can come straight across. And then the derivative of secant is just going to be a memorized rule. The derivative of secant is just secant times tangent. For that second piece, we have two things being multiplied, so I need to use the product rule. So I have the first times the derivative of the second plus the second times the derivative of the first. You could leave your answer like that, first row. I did clean it up a little bit, like sine times negative sine is just negative sine squared. And then cosine times cosine is cosine squared. Be careful, this part is not equal to 1 because that's a negative sine squared and not a positive sine squared. Any questions on that first one?
Yes.
Yes, Mitchell.
So I have a question about the product rule. So it's fg prime plus g times f prime, right?
Yes.
So the order matters, right? It can't be fg prime plus f prime times g.
The order does not matter for the product rule since you're just multiplying and adding. So as long as you multiply one factor by the other one's derivative, then you'll have the same answer.
So like a negative wouldn't affect the overall answer?
No, because you're just multiplying it.
Okay, cool.
So like an equivalent answer for number 1 would have been like 5 secant x tangent of x plus cosine squared minus sine squared. Like that would be an equivalent answer. Where order does matter though is like in number 2 where you have to do the quotient rule. So first off, like a tricky thing that some students have a hard time visualizing, when I say the square root of 5x, that is the same thing as the square root of 5 times the square root of x. And then that way we can just treat the square root of 5 as a coefficient. That is a constant coefficient. So when I do that derivative, I'm going to kind of say this one as I write it out. So remember, I have like the low and the high. So when I take the derivative, I have low d high less high d low. I'm taking the derivative of that denominator now. So 1/2 comes down in front. The square root of 5 was already a coefficient there. And then the new exponent, 1/2 minus 1, is negative 1/2. And then that's all over the bottom part squared. So that's kind of like the ugly version of the answer. This one, it doesn't clean up too much. If I were cleaning it up, it would just be, so we have a secant squared of x times a square root of 5x. And then I have minus a tangent x times, this one's not clean at all, root 5 over 2 square root of x. And then that's all over, well, the square root of 5x squared is just 5x. So not very neat and clean, but that would be the quotient rule. Again, if I'm writing out the formula next to it, so I'm thinking about the numerator as f and the denominator as g. So I have low d high less high d low. Draw my line and down below, the bottom squared will go. The order does matter in that numerator for the quotient rule in the ways how you're subtracting them. And then number 3, we do have the secant squared. Again, if I want to find the derivative of cosecant squared, excuse me, not secant squared, but if I want to find the derivative of cosecant squared, I do want to think of that as a product because we don't really have a rule for taking the derivative of something squared. So again, if I'm taking the derivative of the product rule, even though it's the same, we can still kind of use the rule. So I have the first times the derivative of the second plus the second times the derivative of the first. That would be the derivative unsimplified. If I did want to simplify it, so I have a negative and 2 cosecants being multiplied by each other and a cotangent, and then a negative 2 cosecants multiplied together and a cotangent. Since those are the same, we can treat them like terms. And so this would be the simplified version of the derivative. I often have students ask if they do need to simplify. As you know, half the AP exam is multiple choice, so you should feel comfortable with simplifying. How I will often ask these questions on my quiz or my test, like I might have one question that just says, hey, find the derivative. And you just need to have like a correct derivative as your answer. And then the next question will be like, which of the following, A, B, C, or D, matches the derivative that you found? So you'll be able to earn partial credit, even if you can't do the algebra to simplify it. Again, you should. But again, I do want to be able to assess like your calculus. Can you take the derivative, and then are you able to simplify it when you have to? Any questions on those 2 problems? All right, so that's where I'm stopping notes to give you some instructions of what I want you to do tomorrow. So you know tomorrow is an asynchronous day. So your homework you have to work on, you have homework 4, which is the basic derivative rules, and it's 4 through 52 multiples of 4. What I assigned yesterday is going to be the product rule, and I assigned 4 through 52, again, multiples of 4. Tomorrow, we do know, is an asynchronous day. I do have some notes I need you to view just so that we can kind of stay on pace. You're not watching all the notes on tangent lines. There are some things that I will do on Thursday in class, but in order for me to kind of make it flow, there are some notes I want you to view on Wednesday. So tomorrow. So sometime tomorrow, I do need you to log into Teams. I will have a link posted. There's also an assignment created that will post. I will also text it out and remind, so like you'll definitely see the link. And it's a 10-minute video just introducing you to tangent lines. It's not hard. Like if you can take the derivative and if you remember how to write a line from Algebra 1, that's basically what it is. You can start that homework 6, but again, I'm not going to really require you to start homework 6. I do want you, though, tomorrow to sometime watch that video. And then based on Thursday, we can do like the calculus level stuff of like how can we apply the equation of the tangent line. I will send out, of course, reminders tomorrow since I know there is no schedule, but that would help me and help you out if you can view that video. So at this time, like if you're good to go, like I have nothing else to add to the online portion of the meeting.